Hi, this is Mr. Erdman, and I'm going to talk about 10.2 in geometry, which is the area of a regular polygon. So first we have to understand what the definition of a regular polygon is. A regular polygon has congruent sides and angles. So all the sides are congruent, all the angles on the inside are congruent. Some terms we need to understand is first is the center. The center is the middle of the polygon. The radius goes from the center to the vertex, or this corner. The apothem is a new term. It goes from the center to the side, and that's the side, and it's perpendicular. So it's perpendicular from the side up to the center. And then we know what the perimeter is. That's the outside, so it'd be adding all of the sides up. Okay, so if we look at our polygon here, it's got 1, 2, 3, 4, 5, 6 sides, and it is a hexagon. Okay. So if we want to find the area of this regular hexagon, we can look at a triangle in here. So how many triangles would that hexagon have? Well, it would actually have 6. 3, 4, 5, and 6. So if we find the area of one of the triangles, we just multiply it by 6 to figure out what our area is. So if the area for this triangle would be 1/2 base times height, and our base is S, and our height is our apothem A. Now if we wanted to figure out the whole thing, it would be 1/2 SA times the number of sides. So that's how we get a formula 1/2 A and S if we put them in alphabetical order. That is the formula for the area of a regular polygon. The perimeter would be our number of sides times our side length. So if you look at this formula again, you could also say it's 1/2 the area times the perimeter, which is what we have down here. The area of a regular polygon, 1/2 the apothem times the perimeter, or 1/2 apothem times the number of sides times the side length. Okay. So if we want to figure out the area of a regular decagon with a 12-inch apothem and sides of 8, regular decagon would tell us there are 10 sides. The apothem would be 12, and their side length would be 8. So if we just plug that into our formula, 1/2 A and S, it would be 1/2 our apothem, which is 12, times 10 times 8. So it would be 10 times, hold on a second. So that would be actually 480 inches squared. Okay. Sorry about that delay. And our next problem. Okay, find the area of a regular pentagon with sides 11 and apothem 8. So n pentagon is 5, sides are 11, apothem is 8. And that fits nicely into our formula, 1/2 A N S, 1/2 8 times 5 times 11, and that would give us 220 centimeters squared. Okay, all the problems are not going to be that easy. So there's kind of a process for doing this. One of the other things we have to know is what we call a central angle, which is right here. It would be the actual angle of one of the triangles inside of the polygon. So you find your central angle by taking 360 divided by the number of sides. That gives us the central angle. And we're going to have to use that to figure out the missing parts we need to find out for our polygon. So what we're going to want to do is, for all of our problems, we're going to find A and S. Okay, so if we look at this shape over here, it's got 1, 2, 3, 4, 5, 6. So N would be 6. Okay, our side length would be, this part is 5, this part is 5, so our side length would be 10. Now we have to find out A. Well, to do this, when we do a regular polygon, all we need to do is draw a triangle, because we don't have to draw the whole polygon. So we're looking for A. This is 5, this is 5. Our side length is 10. We need to know our central angle. So 360 divided by 6 is 60. So the whole angle is 60, but we only need half, which is 30. Okay, now if we want to find A, we could use the tangent, or we can use our 30, 60, 90 rules, which I'm going to use on this one. So if this is 30, that's 60. This is the short leg, this is the long leg. So to get from our short leg to our long leg, we multiply by square root of 3. So our apothem would be 5 square root of 3. Once you have A and S, you just plug it into the formula. 5 square root of 3 times 6 times 10. So our area would be 150 square root of 3 millimeters squared. Okay, so same process again. A lot of these are going to get redundant. A and S, because our formula, area 1/2 A and S. Okay, so saying it's a regular pentagon, that means the number of sides is 5. Okay, so we know our side length is 8 up here. So if we draw our triangle, A, we know the side length is 8, the whole thing, so we're going to use half of it as 4. But what is our central angle? 360 divided by 5 is 72. But we only need half, which is 36. So now we can find A, because this is our opposite side, this is adjacent, which is tangent. So tangent of 36 equals opposite, which is 4 over A. Now, if you remember the shortcut, these two are going to switch positions, because if we multiply by A and we divide by tangent of 36, we end up with A equals 4 divided by tangent of 36. You plug that in your calculator. A should turn out to be, I have it, 5.5. Okay, now we have our 3 pieces. So then we just plug into our formula, 1/2 5.5 times 5 times 8. And our area ends up being approximately 110 centimeters squared. Okay, find the area of the regular triangle. What's a regular polygon? So that's n equals 3. Okay, so we're going to find A and S again. If we had our height, we could, in base, we could do that triangle, but we're going to do it as a central, or as a regular polygon. But in here, we have the radius, which is the distance from the middle over here. So it's also a radius. So we need to get our apothem and our side length. So we do this, what we've been doing, draw a triangle, which actually represents this piece in here, A. This is our side length. Okay, now the central angle, 360 divided by 3 is 120. The whole thing is 120. This side is 60. Now, our side is going to be twice this angle. And our radius right here is our 14. This one's a little bit more involved. So what we're going to end up doing is, this is 40, this is 30. So if this is the hypotenuse, to get our short leg, we just divide that by 2. So that would be 7. Now to get our long leg, we multiply by square root of 3, so we get 7 square root of 3. But these two are the same, so now we have to add them together to get our side length. So this would be 14 square root of 3 equals S. So now we have our three pieces we need. We can plug it into our formula. A is 7, N is 3, our side length is 14 square root of 3. So this should turn out to be 147 square root of 3 inches squared. Okay. All right. Going to move on here. So find the area of a regular octagon with a perimeter of 80. Well, we need A, N, and S. The area, so the N is 8. Now, perimeter is number of sides times side length. So if our perimeter is 80 and a number of sides is 8, what is our side length? Well, if we divide by 8, the side length is 10. Now we need the A again. So we'll draw our triangle. A, side length is 10, so half of it is 5. We need the central angle. 360 divided by 8 is 45. But again, we need half, 22.5. Now we're going to have to use a trig function because it's not a 30, 60, 90 or 45, 45, 90. So again, we have opposite and adjacent, which is tangent. Tangent of 22.5 equals 5 over A. So we multiply by A, divide by tangent of 25, which means these two are going to switch positions. So our A equals, if I did this one right, 12.1. Hopefully my numbers are right here. Now we have our A and S. We can plug it in. So it's 1/2 12.1 times 8 times 10. This should equal 484 inches squared, if I do my math right. Okay. Now the next one is a square. Okay. So in a square, number of sides equal 4. Now if we had the side length, we could just square it, we'd get the area, but it's telling us we have the radius. This is 4. So I'm going to kind of draw this. If we have a square, the radius goes to the middle. We got a 4. So I'm going to draw that triangle. This is 4. This is our A. They're half of our side length. Now, what is our central angle? 360 divided by 4 is 90. So this whole thing is 90. This is 45. That's 90. This is 45. So if we want to go from our hypotenuse to a side, let's say the apothem, we take 4, divide it by square root of 2. This ends up 4 square root of 2 over 2, which equals 2 square root of 2. Now you also could do this by doing the cosine of 45, and you could get A. I just did it with a 45, 45, 90 triangle. So A is 2 square root of 2. Now this side over here, because it's a 45, 45, 90, is the same. And then this would be 2 square root of 2. So if we add it, our side would be 4 square root of 2. So we have the 4 pieces we need. So we could use A for 1/2 A and S. A would equal 1/2 times 2 square root of 2 times 4 square root of 2. So our area would be 1/2, 2 square root of 2, actually let's do this way. 4 times 4 is 16, times 2 is 32, divided by 2 is 16. And square root of 2 times square root of 2 is 2. So we end up with 32, what are we in inches squared? Now some of you may have thought, hey, wait a second, I have the side over here. So I could find it out as doing side squared, which is 4 square root of 2 squared, which would be 16 times 2, which is 32. And you could get the same answer doing it that way. All right, our last one, we want to find just the apothem of a regular hexagon. Okay, with a regular hexagon. Oh, the apothem is 15. We want to find the area. Sorry, I messed you up. ANS. Hexagon, N is 6. Now our apothem is 15. We need the side length. So we draw our triangle. Give her S. Okay, this is now 15, our apothem. We need to find this x, then double it to get our side length. So our central angle, 360 divided by 6 is 60. Half of that is 30. Okay, so this is our short leg. This is our long leg. So we're going to kind of go backwards. We could also do tangent to solve it as well. I'll just do it the 30, 60, 90. So we take 15, we divide it by square root of 3, which would give us 15 square root of 3 over 3, which would be 5 square root of 3. This would be 5 square root of 3. So we add them to get our side length, which is 10 square root of 3. You could have also done that, again, with tangent if you wanted to. So now to find the area, 1/2 ANS, 1/2 15 times 6 times 10 square root of 3. So this would end up being, if I did this, 6 times 15 would be 90. 90 times 10 would be 900. Square root of 3 over 2, which would be 450 square root of 3 feet squared. If I did that right. Yep, that's what I got. All right, 2 more problems. So, a regular nonagon has a perimeter of 180. Find the area, ANS. Okay, a nonagon is 9. Now again, perimeter is number of side times side length. So it'd be 180, 9 times our side length, divide by 9. Our side length would be 20. So what do we do here? Well, we got to find A. So draw our triangle, our apothem. Now our side length is 20, so this 20, so this half is 10. We need our central angle. 360 divided by 9 is 40. So this is 20. So opposite over adjacent is tangent. Tangent of 20 equals 10 over A. Divide by A, or multiply by A divided by tangent of 20. A equals 10 divided by tangent of 20 to 10. So A equals, I have the sign here. I don't think I did that one yet. So I will do this on my calculator. 10 divided by tangent of 20, 27.475. So then if we put this in our formula, 27.475, 1/2 27.475 times 9 times 20. Our area would be approximately 2475 meters squared. All right, our last one. Find the area of a regular pentagon. Well, that means n equals 5. Okay, we have our radius here. So This is 4. We need to find our side length and our apothem. So our central angle, 360 divided by 5 is 72. So this would be 36, so the whole thing is 72. This is we're going to have to do two trig functions. So if we want to get our apothem, this is adjacent and hypotenuse, that would be cosine of 36 equal a over 4. So 4 times cosine of 36 would give us a, which if I did this right, is 3.2. Now to get the half the side, it would be sine, because opposite over hypotenuse. Sine of 36 equals x over 4 equals 4 times the sine of 36. So that would equal 2.4. Now, to get our side, we have to multiply by 2, 4.8. So our side length is 4.8. Our apothem is 3.2. To figure out our area, 1/2 ANS. Area equals 1/2 3.2 times 5 times 4.8. That would equal about 38.4 inches squared. Okay, I hope you followed along with that. Good luck on the homework. We will go back over this next class, a little bit on this in next class. But again, try to remember to find your ANS, then you can plug it in. So based on the type of polygon you should have your number of sides. From that, you can find your central angle. Then you should be either given the apothem, the side length, or the radius to figure out what else you need. Once you have ANS, plug it in, and you get your area.